Our next topic in structure of atom chapter is now electromagnetic wave theory. So first we are doing the features of this theory. According to this theory, first point is that energy is emitted from any source of light which is giving out the energy. The energy is emitted from this source continuously. It will not emit that discontinuously, it will be emitted out continuously in the form of radiations and is called radiant energy, and this energy is known as radiant energy. Like for example, if we take this as a source of light, from this the radiations are coming out, and these radiations, they have energy, and these are coming out continuously without any break. This is the first feature of this theory. Next is the radiations which are emitted out by this substance continuously. These, they have electric and magnetic field. They have both the fields associated with them, electric and magnetic fields. That is why the name is electromagnetic wave theory. So this radiation will have electric and magnetic fields, and these fields are perpendicular to each other. In this radiation, these two fields are perpendicular to each other and also perpendicular to the direction of the propagation of radiation, perpendicular to the direction of propagation of radiation. So these radiations which are emitted out continuously, they have both the fields associated with them, electric and magnetic, which are perpendicular to each other and also perpendicular to the direction of propagation. Suppose this is electric field, this is magnetic field, and in this direction this wave is moving, propagating. So all these three are perpendicular to each other. Third point of this theory is the radiations, electromagnetic radiations, they all travel with the same velocity, and that is the velocity of light. So the radiations, they travel with the velocity of light, and that is 3 into 10 raised to power 8 meter per second. And the last point of this theory is that these waves, electromagnetic waves, they do not require any medium for propagation. They can even move in vacuum, they can even move in space. From sun they are reaching to us, for that they are passing through a vacuum. So they do not require any medium for their propagation, for their movement. So these rays, they are coming from the sun and can reach on earth by passing through a space, that is through a vacuum. So these are the 4 points which are given out by this theory, that is energy is emitted from any source continuously, and this is emitted out energy in the form of radiations, and this energy is known as radiant energy. And these radiations have electric as well as magnetic fields associated with them. Both these fields are perpendicular to each other, and these two are also perpendicular to the direction of propagation of the radiations. All electromagnetic radiation, they travel with the velocity of light, that is 3 into 10 raised to power 8 meter per second, and these waves do not require any medium for propagation. They can even move in vacuum. So these are the points given by this theory. Now we are doing the characteristics of a wave. What are the characteristics of a wave? So we say that wave is actually made up of crest and troughs. And what are the characteristics of this wave? Suppose we take this as one wave. It's moving like this, forming the crest and forming the troughs like this. So now we have to do the characteristics of this wave. First characteristic is wavelength. Wavelength is denoted by a symbol lambda. It is the distance between any two consecutive crests or troughs in a wave. So suppose these are the two crests we are taking. This distance between any consecutive crest, or if we take the troughs, between any two consecutive troughs is known as a wavelength. And it is expressed in, symbol we are using is lambda, while it is expressed in angstrom, in picometers, angstrom. And 1 angstrom we know is equal to 10 raised to power minus 10 meters we take. Second characteristic of wave is frequency. For frequency, symbol is nu. V and then tilted like this becomes a symbol for frequency. This is called nu. What is frequency? This is a number of waves which are passing through a given point. Number of waves passing through a point, but in how much time? In 1 second. In 1 second through one point, how many waves can pass? That is called its frequency. And this frequency is expressed in units are hertz, or we can say per second. We can use per second or we can use hertz to express frequency. So suppose this is one point we are taking. Through this point the waves are passing. In 1 second, how many waves can pass through this point? That is called its frequency. Coming to the third characteristic of wave, that is velocity. For velocity, we use a symbol V, and if it is light, then we use a symbol C for it. And what is velocity? It is the distance traveled by a wave in 1 second. In 1 second, how much distance a wave can travel? That is called its velocity, and it is measured in meter per second. Next is amplitude. For amplitude, the symbol is small a. It is the height of crest or the depth of trough. And since this is also a distance, so this is also measured in the units of distance. This maximum height of crest or this maximum depth of this trough, this is called amplitude. Next term after this is wave number. Wave number, the symbol is nu and bar on this. Nu bar is a symbol for wave number. It is the number of waves in 1 centimeter. If we take 1 centimeter distance, how many waves are there in that 1 centimeter? That is called wave number, and it is equal to 1 by lambda. Nu bar is equal to 1 by lambda. If we take the lambda unit as centimeter, then nu bar will be per centimeter. So these are the characteristics of a wave: wavelength, frequency, velocity, amplitude, and wave number. After doing the characteristics of wave, moving on to the next topic, that is electromagnetic spectrum. Now, what is electromagnetic spectrum? All known electromagnetic radiations, when we will take, we'll do the examples of these now only. All these known electromagnetic radiations, if we start arranging all these in increasing order of their wavelength, like I'm taking cosmic rays, lowest wavelength is of the cosmic rays. After that, gamma rays, this I'm arranging according to increasing wavelength. So when we arrange them like this arrangement only is known as electromagnetic spectrum. And these are the examples of electromagnetic radiations. These are cosmic rays, gamma rays, X-rays, UV rays, visible rays, infrared rays, microwaves, and radio waves. And we have to do one formula, that is relationship between frequency, velocity, and wavelength, C equal to nu lambda. So if I'm saying in increasing wavelength, I'm arranging, I can say in decreasing frequency, I'm arranging also. So these radiations you can say are arranged in increasing order of wavelength, increasing order of wavelength, or we can say this is decreasing order of frequency. So this arrangement only is known as electromagnetic spectrum. And in this electromagnetic spectrum, this visible portion, if we'll take just this part, if we'll take visible one, this is actually further when we expand this visible portion only. This is made up of further 7 colors. And that is called Vibgyor. Vibgyor. So just a small portion of electromagnetic spectrum, that is a visible portion. When expand this further, this is made up of 7 colors, that is from the violet towards the red. The lowest wavelength here is of the violet and the highest wavelength is of the red color, that is the 700 nanometer approximately. This whole thing is known as electromagnetic spectrum. So this is our topic for today, that is what is electromagnetic wave theory, characteristics of wave and electromagnetic spectrum.